have a birthday shout.
Hooray!
We're here to sing to you today. 1 year older and wiser too. Happy birthday to you.
Yeah, Carmen! That girl.
All right, very good.
Turn it up.
Yes, and there is another birthday person.
Oh.
Well, thank you, Carmen, for allowing us to recognize you on your birthday. Hope it's she's making the correct observation. She asked, was it my choice? Well, no, it really wasn't. But she went along with it well enough. And Carmen, here, something else here. Let's see here. There you have it.
Can I use the bathroom?
It's still on camera, man.
Here we go.
Oh my gosh.
Here we got
I've
your
done
ladies. Oh,
I don't have a job.
Good chair.
Is that actually thunder?
Can we check the weather?
No.
Hey, if it's about to
Yeah,
rain,
we'll
can I go get my umbrella?
No. We got class, guys. Class time now. All right.
Yeah, there's a 40% chance of rain.
Alright, oh, I'm gonna melt.
Really dark. Oh, that's it.
Look at which of the list.
Man,
I'm trying to order it now.
I remember last year I said
That's all we got.
What I'm including a piece of graph paper with this because with the graphing here, it might be helpful to you.
I don't want it.
don't take it.
Yeah.
That's yours.
Hi, what do you think, Cal?
Nice shirt, Mr. Jeter.
His
Weather.
name is, I said, what do you think?
Y'all wanna see the forecast?
Yes. How many days?
It's a rain.
Yeah, those are 40% chance. Hey, yo. how
And the
many
people
days
watching this
freeze
video are
there?
like, yeah, it's raining right now, so,
But it's not.
Yeah, exactly. Good point.
I cannot see it.
I can't read it.
where do you go out?
I have the contacts,
Hey,
Will.
yo, how many days do you need?
They still don't work.
Oh.
All right. What we're doing is we're getting into chapter 2, and chapter 2 has to do with polynomial. Kinsey.
Sorry, I was on the.
Polynomial, power, and rational functions and equations. So we're gonna learn all about those, and we're gonna do a quick review today, which sort of preliminarily goes over some of the things we're gonna be doing for this section 2.1. And so let's go ahead. And just from having had 5th period class, there were some things they had to remember, and maybe be the same for you. Okay, so for 1 and 2,
That was pretty easy.
write an equation in slope-intercept form. So what do we have to know for this?
MX must be.
So we have to know
Good job, Em. Thanks.
That's why you made
y
this
equals mx plus b. Yes, Chloe told us that in 5th period. Thank you, Emily. And so we have, our equation is going to be y equals 8x
3.6.
plus 3.6. Okay, so that's pretty simple, and 2 should be similarly simple. Similarly, so this is going to be minus 2, right? Really, really simple. Okay,
Wait. Yes.
right?
Right.
Right. Is this too easy to mention? Yeah,
We
kind
should
of.
know this.
Should know, but something that sometimes we need to be reminded of anyway, right?
This is basically film like.
Now, 3 and 4, write an equation for the graph of the line containing given points, graph the line and the points. So I want you to go ahead and try that. And it's for number 3 and 4 that I gave you the separate piece of graph paper. Because there was actually a grid printed out here, but it didn't show up in the copying. Okay, I'm seeing most people looking like they're working on this.
Is my mom coming?
Mr. G, did you see the clouds outside?
No, I didn't, but I hear some thunder.
Dark,
Really
dark.
dark.
But really, what's interesting about it is it's sort of light, the sky is pretty light too.
All the rain is towards Kaufman.
Oh, really? Okay. It's probably one of those summer showers that's gonna go over us and leave pretty soon, that's my guess.
When's fall?
Pardon me?
When does fall start?
Fall start?
Yeah, when does fall start?
Well, fall starts, I think, usually on the 21st, so early next week, yeah. Which is the
Not right.
equinox, it's the halfway point of the sun.
Did you say it's not drought this time?
All right, how did you do on this one?
Yeah.
Okay, I think you got it. Okay, I want to show you a way to do this that I've been doing for quite a few years now, that some people like.
Scatter plot.
And, well, you could do it as a scatter plot, you could, yeah. Is that the way you did it in the calculator? Angel, is that how you did it?
What? Why do you have a chain?
E-boy.
So, we're gonna have,
Under wraps.
G-Dog.
we're gonna have the,
Oh, his shirt even says G-Dog.
yeah, this is my, so anyway, yes.
Oh, everything.
Fresh. Your whole head's not.
All right, guys, here's what I need. I need help with the beat on this. Let me tell you what I want. I want pretty slow. That's pretty good.
Your head's not all the way in.
You can find the rate of change. You can find the slope. I'll show you how to do it. Have a little hope. Take at least 2 sets of coordinates of x and y for each. Now make a T-chart too. Now it's within your reach. X values on the left, y values on the right. At least 2 points are needed to prove that you are bright. And then you draw the arrows, both of the sides, and calculate the differences. You can do it if you try. Either bottom from top, or top from bottom. The same way on each side, and your answer won't be wrong. Pretend that you're a baseball player, right hand over left. Now calculate that slope. You proved you're not a dope. If all the slopes are equal, then you proved you had a line. If not, then maybe it's quadratic, or something just as fine. But x equals the numbers of vertical line. It's called no slope, infinite slope, or undefined. But y equals the number is a horizontal line because the coefficient 0. The slope is 0 every time. Now take it to the finish. Take it to the house. Listen to the G-Dog, and you won't be a louse.
Oh,
So really, that's it. I don't know what happened
Where'd Mr.
to,
G go?
I don't know what happened to my screen here.
She's gone.
There it is. I'm glad it showed up.
G-Dog out.
But here's what we have. I don't know if that's helpful to you. It's
Oh,
something
no,
I've
it
been
was.
doing for
It
years.
really was.
You liked it?
I did.
Was it slightly entertaining maybe? But what happened is another teacher friend of mine named Oswaldo came up with something called a 3-column process chart that helped work toward getting an equation out of this, and I want to show you how to do it. If you take what you do is you take a T-chart like we have it, but you separate out. So I'm going to take this, I'm going to separate this out. No, I'll leave this m equals -3/5. Okay, I'll leave that there. But if you separate it out here, we have xy and -2, 4, and 3, 1. And so what you do is you use this mx plus b is equal to y. And so -2, and what is m? -3/5. So I'm going to put -3/5 x, which is -2, plus b is equal to 4. And what can we do with this equation now?
Solve for B.
Solve for b.
She right.
So -2 times -3, 6, right?
Yep.
So we got 6/5 plus b, and how many fifths do we have in 4?
That'd be 20.
20/5, okay, very good. No, that is good, because I've asked that same question for years and years, and that's really awesome work right there. So we subtract out, what do we get for b? B is equal to
14/5.
14/5. So now do we have an equation? Yeah, we do. Y is equal to -3/5 x
Plus 14/5.
plus 14/5. Somebody yelled out 3/5 x.
3/5 X plus 14 over.
14/5.
Five.
So this is where that came from, right?
Yep.
So this came from there, and this b came from here. And the last thing we do is we're going to test. It says graph the line and the points. So let's go ahead and do that. Graphing. How do we graph our line? How do we graph our line?
Use
Calculator.
use the
Rise over
You
slope.
plug in those points.
Yeah.
Or you can use the slope, or you start.
Okay, we've had a song all about this last year. What was the song?
You gotta count your points one by one.
Count the points one by. So we start with the y-intercept. Find the y-intercept. Where's the y-intercept? 14/5, right?
Into them.
And then we do the rise over run. What's our rise? What's our rise? 3. What's our run? 5. 1, 2, 3, 4, 5. So now our line's going to look something like this, right? Yeah, it would look better if I could draw straight, which I can't. I did better at this part of it last. So that's pretty good. And then you test your points. So we should have -2, 4. Is that right? And 3, 1. Okay, so that worked out right, didn't it? So does that work out for us? Yeah, it does. What else could you do to check further if you need further checking?
calculator.
Yeah, a calculator, or that was what I was thinking, but Will's right about that too. But you could also check this one too, right? To see if that works. And so, what I want you to do is, and somebody mentioned just taking the scatter plot of that. You could actually do that with 2 points. Is that what you did, Angel?
Yeah.
Yeah, you could. So I want you to look at number 4, which is very similar to this, and work out number 4. I'll have you know, you guys did better than fifth period class on the rap. And, but this class, you guys are good usually at singing and stuff like that.
I'm such a good singer.
No, truly. And so, good job. And the other class is a good class too, but it's smaller and more quiet. So did you finish this one, or are you still working on it? Emily, did you finish this one yet?
Still working, I'm still working.
You're still working on it? Looks like most of you are working pretty well. Including the birthday girl? How's the birthday girl doing today? Birthday girl, how are you going to celebrate tonight? You going to eat pizza? All right, man, that's good. That's about as good as a birthday celebration I can hope for.
At your house? Oh, they would, yeah.
Oh, we are? Tonight?
You're going to Cece's tonight? Where is Cece's located? It's in Coffee. Oh, in Terrell? Terrell.
What is it to do for number 5?
What's that?
What is it to do for number 5 today?
Okay, yeah, let's just, number 5 is expanding, yeah, just multiplying out. Let's go ahead and do this one quickly. So this one here,
Good one, Carmen.
so,
Hey, there's Emma. Come back. Shut up, Carmen.
so what'd you get for this one?
The slope.
So what is your slope gonna be? 83. Now, in the prior class, I had somebody who got these reversed and got like 3/8 instead of 8/3. Why is it 8/3?
Because wise.
Rise over run. Very good. Very good, Kinsey. Kinsey, coming through, Kinsey. All right. So next, we can use the same thing. Did anybody do it this way?
Yes.
Did it that way? Did that work out for you? You think that's a helpful little thing? Osvaldo, and the guys are so mx. So we have y equals mx plus b, and here's our m is going to be 8/3. Our x is 1 plus b is equal to 5. So I'm saying 8/3 plus b, and how many thirds do we have over here?
Oh, 15.
15 thirds. And we subtract out,
So 7/3.
so we have b is equal to 7/3, is that right? And so we have our equations, y is equal to 8/3 x plus 7/3. I did have and so to graph, we go to b, which is this, right? And then we have 8/3, 1, 2, 3, 4, 5, 6, 7, 8/3, something like this. Is that what you got? And then you have a line that looks something like this. And then we test our points, 1, 5. 1, 5, is that about right? And then our other one is -2, -3. So how confident are you this is a correct answer?
100%.
100% correct, good. One thing that I had from it was Riley in the 5th period, she was asking about decimals versus fractions. And we had a good discussion about that.
It's easier to do fractions, right?
You think it's easier to do
It's more
fractions?
accurate. Isn't fractions more accurate?
Well, I'll tell you what, so Hannah asked a very good question. She asked, aren't fractions more accurate? Well, it depends. On this one, yes. Because what would a decimal be? A decimalized would be 2.333, right? This would be this 7/3 would be 2.333, which wouldn't be 100% accurate, but this would be. But if we go back to this one, you could actually make a decimalized version that's perfectly accurate, couldn't you? Negative 0.6x plus 2.8. So here the decimalized version is perfect, but not here. But what happens as you go into higher mathematics, which I definitely consider precalculus to be, you're sort of educating yourself more in the fineries of fractions and the geekery of more advanced thinking, if that's what you want to call it. So you can make arguments either way. One thing I like about the decimalized version is a decimalized version like this one here is sort of easier to be intuitive about, because 2.8 to me is more intuitive than 14/5. And so they each have their pros and cons. But that's still a very good question, Hannah. And again, to Riley in 5th period, I say thank you again. Okay, now we are, Angel, you talked about expanding this. And what you should have gotten for this, and correct me if I'm wrong, is x squared plus 6x plus 9, is that right?
Yes.
Yeah.
Now how did you do that?
Box.
Box, so Hannah went like this. And Hannah, correct me if I'm wrong about this too. So she puts x plus 3, x plus 3, and then like this, Hannah,
Yeah.
and thus she has x squared plus 6x plus 9. Anybody else do it differently than that? In 5th period, I had one student, Chloe, who did this. Has anybody ever seen this thing here?
Yes, but it confuses the heck out.
It confuses you? Well, to me, it doesn't confuse me as much as I've done it, but you can see x squared plus 3x plus 3x plus 9. But I'm kind of with Kaylee on this one. And the reason, did you use the box method too, Kaylee? You did? What's the reason you like? If you're a fan of the box method, Hannah or Kaylee or anybody else, why do you like the box method better?
It's easier to like see, like you can see everything and it's not like.
And it's easier to combine like terms because you can connect and circle how you did.
Yeah, easier. Okay, commenters are saying, Emily's saying easier to combine like terms. That's true too. Hannah's saying easier to see. Kayla, what do you like doing? Which way do you like doing this?
The 90
I
way.
did this in my head.
So you did it in your head. So I want to show you, I want to give you another alternative way of doing this that's more or less in your head. What you do is, if you take the first term squared, what's the first term squared?
X squared.
So x squared plus 2 times the first and the last. What's the first times the last?
3x.
3x. What's 2 times 3x? 6x, right? Plus last term squared. So you can do it that way too. And one thing we're going to do this year, later on toward the end of the semester, is binomial theorem. In the binomial theorem, if we have something a plus b squared, it's going to be a squared plus 2ab plus b squared. And so we're going to develop that a lot further later on toward the end of the semester. Okay? But all good observations here, good discussion. And this one here, if we do the same thing, which is first squared, 2 times the first times the last is minus 8x, and the last squared is
16.
plus 16. Okay, so that would be that one. Okay, pretty simple? Okay. Questions on this one? Okay, we're gonna go on. This one, we have another expansion, couple expansion problems.
Do you distribute first?
Who, you said distribute first?
I don't know, I was asking.
Okay, she asked distribute first. Okay, well, what's, if you distribute first, what happens?
Then you get like 9x
Yeah,
squared
if you do that, if you distribute first, what you're gonna get
you're squaring all
is
this stuff that
you get
shouldn't
3x minus 12, and then 3x minus 12,
18.
right? And so this wouldn't give you a right result. And the problem is because what you're really looking at here is you're really looking at, what you're really looking at is 3 times x minus 6, x minus 6. That's what you're really looking at. And so you're only going to distribute,
So you distribute after.
Yep.
yeah, so you can distribute like this right now, or you can multiply these two together first, then multiply by 3. Most people will multiply these together first, then by 3. But that was another good question, Hannah. Hannah's on fire today.
Get a fire extinguisher.
Who else is on fire today besides Carmen, birthday girl? Kaylee, are you on fire today?
The one girl from Hunger Games.
Oh, yeah. Okay, so what you should get for this, and correct me if I'm wrong, is 3x squared minus, is it 54?
36.
It's 36 minus 36x, thank you, plus 108. Did everybody get that? I hope you got it. And then for this one here, you should get negative 3x squared minus 42x, thank you, minus 147. That's what you should have got for this one, is that right? Yes, no, maybe, sometimes? Emily's, yes. Okay. Next. Factoring trinomials. So what you're going to try to do first is look for a common factor. Is there always going to be a common factor?
No, there's a 2.
But Kinsey says there is. So Kinsey,
It's a sticker?
well, I don't want to call Kinsey a liar today. Maybe on another day I'll call Kinsey a liar, but I don't want to do that today.
Oh, well.
And so what is this going to be here?
X.
It's just x minus 1, x minus
And then if we wanted, we can do this too, right?
1. Yeah. I put 2x minus 2 and then x minus 1.
Okay, so what, here, I'm going to put a little sidebar. So Will did this. He distributed back here, and so you end up with 2x minus 2. So it's going to be x minus 1. But what's wrong with this? What's wrong with
It's not
this?
completely done.
Not completely factored. Okay, So you're gonna wanna keep that 2 outside of here. And so this is why that's not, in this instance, the correct answer. Okay, that's a good idea to do. And sometimes it's gonna be to your advantage to do that. But in this case, not. Okay, so that's our answer for that one. And then we have 10, which is pretty similar to number 9. Any questions on these, ladies and gentlemen? Okay, I guess.